Greetings, everybody. This is Zach Beckstrom again, and today we're going to be talking about Chapter 4.2, Pyramids and Frustums of Pyramids. Now, we have a little bit of an issue today because I'm at the school and they are testing fire alarms. So if it happens to go off in my office while I'm doing this, I'll probably pause it and then continue when they're done. Just a little pre-warning, but everything should be all right. I hope everybody's doing well today. So let's go ahead and take a look at these two things here. So first, let's define a pyramid, and more specifically a right pyramid. So a pyramid is just a solid object with one base and three or more lateral faces that taper into a single point that we call an apex opposite the base. You can see here these are both pyramids. Now a right pyramid is one whose base is a regular polygon. Remember, a regular polygon from the earlier section is a shape with all equal sides and equal angles, and whose apex is centered over the base. So if you look at this first figure here, you'll see that we have a regular square polygon base, and the apex is centered directly over the center of that base. This pyramid here is not a right polygon or not a right pyramid. You can see it does have a polygon base, but the apex is centered to, if in this position, to the right of the center. So what we're going to be talking about in this section is mainly the right pyramids. Alright, so let's take a look at the first formulas we have. So we can figure out the lateral surface area, the total surface area, and the volume of a pyramid. So take a look at this pyramid here. The bottom of the pyramid, this is the side that's opposite our apex, is going to be considered the base. The distance between the center of the base and the apex is going to be our altitude. And the distance halfway across one of the edges going up to the apex, that will be our slant height. Alright, and take a look at the three formulas we have. Lateral surface area, that's just these four sides for this right pyramid. That would be 1/2 our perimeter of our base times the slant height. That's the slant height right here. The total surface area would be notice our lateral surface area plus the area of the base. So remember, the lateral surface area is the area of everything other than any bases. And the total surface area would include the area of the base. So we just add that in. And then the volume is 1/3 times the area of the base times our altitude. Alright, and remember, the altitude is always going to be perpendicular to the base. Okay, so let's look at an example here. Let's find the lateral surface area, total surface area, and the volume of this right pyramid here. So we see that it has a square base with sides equaling 6. Has a slant height here of 5. Has an altitude or height of 4. So we should be able to figure out all of this information. We know that it's going to ask for the perimeter of the base, so we can kind of easily check that. That's going to be 6 times 4, which is 24, and it also may ask for the area of the base. That would just be 6 times 6, which is 36. So go ahead and try that on your own. See if you can come up with the correct answers using the formulas we've already gone over, and then we'll take a look at the solution. Alright, so the lateral surface area is 1/2 times the perimeter of the base times the slant height. We've already said that the perimeter of the base is 24. The slant height is 5, so 1/2 times 24 is 12. 12 times 5 is 60. The total surface area is just basically that that lateral surface area, which is 60, plus the area of our base. And we said that was a square with a side of 6, so the area is 36. So that would be 60 plus 36, which is 96. And the volume is 1/3 times the area of our base, which we've already determined is 36, times our height or altitude, which is 4. So 1/3 of 36 is 12. 12 times 4 is 48. Alright, so let's look at the second figure that we'll be looking at for this section here. This is the frustum of a pyramid. So the frustum is basically if you take a pyramid and you slice through that pyramid in a way that's parallel to the base of the pyramid, the bottom part of that is going to be considered what's called the frustum of a pyramid. So it's basically everything from the base up until where you sliced the pyramid off, just like in this picture here. Alright, so we have some formulas for that as well. So the lateral surface area, it's going to be these things here. You notice that formula looks very similar to that of a trapezoid because the sides of this frustum do in fact make trapezoids. And then the total surface area is going to be our lateral surface area plus the areas of our two bases, our upper base and our lower base. And then the volume is going to be, this is kind of a harder formula. We need to make sure that we apply the order of operations in the correct order. It's going to be 1/3 times our height or altitude, and that's going to be multiplied by all of this together. This is the area of our lower base plus the area of our upper base plus the square root of our lower base area times our upper base area. And once again, let's make sure that we do this in the correct order, and we'll take a look at that. So let's look at our final example here. Find the lateral surface area, total surface area, and volume of the following frustum. And as you can see here, we're going to have a height or altitude of 4 centimeters, a slant height of 5 centimeters, and a bottom base here of 6 centimeters, and the top base side here, the upper base side, is 3 centimeters. Alright, so go ahead and see if you can find those, and then we'll get back to that. Alright, and what do we have here? We have the lateral surface area is going to be 1/2 times the perimeter of the upper plus the perimeter of the lower base times our slant height, which if we plug all that in, our upper base perimeter is 3 plus 3 plus 3 plus 3, or 12, and our bottom perimeter is 4 times 6, which is 24. So that's 36. Half of that is 18, and 18 times 5 is 90. So the lateral surface area is 90 centimeters squared. The total surface area is, we take that lateral surface area and we add in the area of the upper and lower bases. You'll get 90 from our first equation, plus the top upper base is going to be 3 times 3, which is 9, plus the area of our lower base, which is going to be 6 times 6, which is 36. Add all those up together, you should get 135 centimeters squared. And now the volume. So this one is pretty crazy, and I'm going to tell you how we can do this in an order of operations type way to make sure that we get the correct answer. So looking at this formula here, remember with order of operations, we do what's in parentheses first. So there's a large parentheses, and then there's a square root here, and we're going to treat the square root as a parentheses as well. So you're going to want to first do this, the a1 times the a2, and then you can take the square root of that, and then you can add these three up together, and then you can multiply that by the height, and then multiply that by 1/3, or dividing by 3. That's going to be the same thing. So if you do it all together, and I did a couple of steps here, you should get 84 centimeters cubed. Alright, well thank you so much, and make sure to email me or give me a call for any questions, and I look forward to our next lesson. Have a good day.